Okay, now today we look something a bit different. We look at absolute dependent motion analysis. What I mean by absolute dependent motion means you move one point, another point will also continue to move. Like this object that you see on the screen here. If you move this rod, this mass will move up, and this pulley will move up, and so on. All right. So we look at pulley system for this session. So how do we solve this kind of pulley problem? Let's say you have two objects, object A and object B, and you always have an origin point. When you pull A, what happened to B? When you pull A down, B will move up. So when you have a center O here, how you measure distance? We're still applying position and acceleration. So A to C from origin, you see the arrow. When you solve this kind of problem, be careful looking carefully on the diagram that is given. You will given a dot and an arrow, for example, as A. What does it mean? Positive direction from this datum to this arrow is positive. Same apply to B. B, you see the dot and arrow, so positive going down according to this diagram. So when you pull A, SB positive, negative? Negative, because it's move up. Correct. Okay. And according to this diagram, AC, CD, DB is a constant. It's a constant length, right? Correct. Then, when you pull A, distance A will change. Distance B will change. Will CD change? No. So you have to aware what is changing, what is not changing. So when you talk about absolute dependent motion, first position we label as S, again, same. And if it's referring to object A, we label as SA. If you refer to object B, then we use S sub B. Okay. Now you should able to label clearly when you solve this kind of question in your assessment, in your test or final exam. Label carefully, label clearly. So yeah, this one already mentioned, fixed point and where is the positive and negative direction. Okay. Next one. How do we solve this kind of problem? We have something to refer to, which is the total length of the cord or total length of the rod or total length of the chain or something, right? So total length, how you calculate total length? As AC plus CD plus DB, right? So your calculation, your first line of calculation, you need to write L total or L equal to SA plus LCD plus SB. Then you are interested in velocity. When you pull this one move how fast, right? So we deal with velocity. Position, how you get velocity? You time differentiate the position. So when you time differentiate, this one become SA become position become. You differentiate position, what you get? Nicole, when you differentiate position, what do you get? When you differentiate position with time, what do you get? Velocity. So you get velocity of A, so you VA. When you differentiate the length of CD, what do you get? You differentiate distance, you get distance. This is position, right? Huh? Speed, what is the value of speed? Okay. The CD change. So what do you get? 0. Huh? Doesn't change what? Then SB, S is a position or displacement. Displacement, you differentiate with time, what do you get? Velocity of B. Okay. So this one, you dot this one, you get, okay. You differentiate SA, SB, right? You'll get VA plus VB, right? Then this one constant, this one also constant, right? So when you differentiate total length doesn't change, you get 0. So 0 equal to VA plus 0 plus VB. You rearrange, you get VA plus VB equals 0. Okay, so this is how you derive the equation from the total length to velocity. Okay, and this equation will change when you have more than one set of pulley. This is only one set of pulley, one rope. But later, when you come to your test or final exam, you will not see something simple as this. Okay, so you will develop your understanding from what you learned today. Okay, so you can rearrange this equation, either move to left or right. So VA plus VB equals 0. You move your VB to the left or you move your VA to the right. You'll get VB equal to negative VA. What does it mean? What does it mean? It means, what mean by negative? Different direction. So when you move A down, A move down, B move up. Or you move B down, A will move up. Again, why negative? Where is the positive? You refer to the datum. The negative positive sign, you refer to the datum. Huh? Okay. You do the same. You time differentiate velocity, VB dt. What you get? You get acceleration of B. dA over dt, you get acceleration A, but still negative. Again, acceleration, now you get negative. What does it mean? You slow down the object. Okay. Let's look at more complex one. If you understand the previous one, this one you should be able to do. Huh? So now we have how many pulley? We have 3 pulley. But in total, how many rope you have? We only have 1 rope, which is connecting this point until here. Okay. Now, this kind of problem is very easy to solve. Right? First step, you always find the total length. Then you differentiate. You still start with the position where you find the total length. Then you go velocity. Then you go acceleration. Very simple. So first important is where is the positive? Look carefully in the diagram. The datum will be given. Always referring to datum. Huh? Datum, when you change datum, the positive negative sign will change in your solution. Okay, for example, the top one, datum SB, where is the positive? Going down. The SA, datum at the bottom change. Huh? For A, datum is moved to here and not here. So datum for A is referring to this bottom line here, positive to the right. Okay, before you solve, you try to think logically. When you move A to the right, what happened to B? What is the motion of B? If you move A to the right, what happened to B? Yes, B will move up. Make sense? Okay, so you have this kind of logic thinking and hypothesis, then you can do this question. So first, we always see where's the positive, where's the negative. Huh? So you know that as A move to the right is positive. When you pull A to the right, block B will move up. But you see the datum B. Datum B positive go down. So you'll get negative sign for between A and B. Okay, bear in mind that. Right? So all this you read, same. You look at the position, look at where is positive, where is negative, look at the datum. Right? Then the next steps. Next step, always go for total length of the chord or total length of the line. So how do you calculate the total length? Nico? Okay. Okay, you take, okay. Your answer is SB L total equal SB plus H SA. So this is total length. Okay. Chong, you agree? Chong, huh?
That's not the total, right?
No. What is the total length? This equation, right? Chong, you agree? LT equal to 2SB plus H plus SA. Chong explain to Nico why 2SB. See this one, SB plus SB plus H plus SA. Okay, so be careful when you interpret the diagram, huh? Because if you lack of one of the length, the rest answer is sure wrong already. Okay, so total length SB plus SV plus H SA equal to L. So you have 2SB H plus SA. Okay, makes sense here? All right. Now, once you have the total length, next you want to find the relationship between SA and SB. Right. So here, before you move on, you know that the next step you want to find velocity. So you integrate this yellow color equation with time. So SB will become velocity. You get 2 VB plus H. H, what do you get? 0, because H doesn't change. You fix already. Pulley here and pulley here, fix already. All right, fix already, doesn't move. So your H is constant. So H is 0. SA become VA. Total length doesn't change. So L become 0. The LDT becomes 0. Okay, so you rearrange SB 2VB plus VA equals 0. Right? You move your VA to the right. You get 2VB equal to negative VA. Makes sense. So this is the relationship between your velocity of B and velocity of A. What does it mean? Means that you need to move 2 times faster to get the same speed of A. Okay, 2VB equal to 1 of the VA, but different direction. Makes sense. So the yellow color equation you see on the screen here is very important when you solve absolute dependent motion. Okay, the rest is substitution. Okay, you change VB to acceleration. Same. All right, VB differentiate with time, you get A. VA differentiate with time, you get VA. Okay, the three equation you see on the screen is important. Huh? Okay. Okay, the rest already explained what I mean by positive, what I mean by negative. Do you see the difference between diagram A, diagram B? What is different? Can you observe the difference? Okay, the datum changed already. Where you added, you see diagram B on the right. You see there's added one more datum for B. On diagram A, your B is referring to the top datum, but the diagram on the B, the datum is changed. So you will get this different equation if you are given different datum, right? So same, first step, total length. Total length, you take this one, but you cannot directly take SB anymore. You need to take H minus SB to get this length. So we have 2. So 2 H minus SB, makes sense. Then H, then plus SA. You get different total length equation if you change the datum. Then you need to rearrange this one. Then the next step is to do time differentiation, get velocity and acceleration. Okay, so this one you move 2h plus h, you get 3h, but you differentiate with time, you still get 0. Then 2sb minus 2sb plus sa, you differentiate, you get 2vb minus 2vb plus va equals 0. You rearrange, you get positive value. Positive, positive. So there's a difference between the previous diagram and diagram B. So, but the procedure of solving still same. Find the total length, find the velocity, find the acceleration. Okay. So again, be careful on the datum. All right. Okay, you should be able to solve. Huh? All right. So, all right. Okay. Let's look at this diagram. Tutorial question number 15, or example 15. Determine the speed of A if block B have upward speed of 6 meters per second. Okay. So, first steps. Find what, Nico? First step. Total length equal A 3SP. Any more? That's it, huh? Correct or not? Okay. Then, next step, do what? Next step, do what, Nico? Differentiate. So this one you get 0 equal VA plus 3 VB. Rearrange. VA equal minus 3 VB. So you get this one, this one. What about A? Acceleration equal minus 3 AB. Okay, good. Let's check the answer. So positive go down for both case. As A go down positive, as B go down positive. All right. And the red color one, we consider same. So those doesn't change. So before you move forward, try to analyze logically. When you pull A, what happened to B? B will move up, huh? All right. So that's why you check your answer. They should be negative between A and B. If you get positive, then you need to check. And there should be something wrong from the derivation. Okay. So we add all. L equal to SA plus 3SB, which is correct. Then you do time differentiation. You get 0 equal to VA plus 3VB. You get minus VA equal to minus 3VB. But you're given, determine the speed of block A if block B has upward speed 6 meters per second. So you know that VB move up, right? So move upward is negative. So when you substitute inside, you will get 18. Right? So VA equal to negative 3 bracket negative 6. You get positive. Make sense? So yeah, make sense to you? The question, the answer, right? So just be careful on the positive negative sign. Right? Yeah. Although the question didn't tell you positive negative, be careful on the datum. Right? So although this on the diagram B here give you positive, but look at the datum. Datum positive go down, but this one go up, so you get negative sign. Okay, so these are this one.
Previous,
Mm.
I think the question, I mean, first few
Mm.
answers, we can assume that if an object is going up or down, right?
Oh, okay, yeah. But it depends. Sometimes question will, in a question they will tell you already. They will tell you either you pull A or you pull B. Okay. Now another type of question will come out like you're given the mass. Let's say by this diagram that you see on the screen, the mass of A will be lighter than B, right? I mean, based on this. So what happens if you know that if you assume A is lighter than B and you hold it, then you let it go. You let the gravity do the thing. So what happened to that system? B will go down, right? Of course, the velocity won't be given anymore if it's free fall condition. So you sometime which object go up or go down, you read the question. Okay, so in this case, it gives you B push up from the diagram. When you push B, A will go down. Okay, let's do this question. Example 16, see if you're able to understand. Still the same. First, find the total length. Then you differentiate time, get the velocity. Differentiate time, get the acceleration. So look at the datum. Where is the datum? Find the total length. So this one, total length equal SA plus, you're going to get this length, right? 2SC, then this one, right? SP. Okay, so any more? Here. No, here, here, and here. And here. Okay, so we have one more. How to get this one? You get SB minus SC. Right. Then you are given the initial velocity, 6 meter per second. You push up this object B. What happened to A? Will go down. So you know that from this diagram, when you move B up, A will move down. So there is a negative sign between A and B. Right. So same, you can see from the diagram. The rest you read, huh? Still the same. L1, right? L1 will be SA plus SC, SA plus 2SC. You get the first chord. So this solution, because you have two rows, you have two separate rows, so you cannot act as a total length. You need to do two separate procedure. First, you find the length number 1 or rope number 1, then continue with rope number 2. Right? Rope number 2 is here, SB plus SB minus SC. Right? So when you solve relative motion, don't straight away jump into the calculation. Look carefully how many lines you have. Example 14, 15, you only have one rope. This case, you have two ropes. So you have L1 and L2. Okay, next step, say find velocity. Right? So here also you have three constant also. You have A, B, and C constant. Right? All right. So time derivation, the first one, L1 becomes 0, SA become VA, SC become VC. Second one, what do you get? 0 equal 2 VB minus C. Okay. But the question always asks you what happened between A and B. It doesn't tell you what is C. You don't need, sometimes the question will ask you the speed of C. But here you have three unknown. You have two equations. They're not solved, right? There's one more. How to eliminate C? You rearrange the equation. You take B, substitute inside here. Okay. You look at the second equation, 0 equal to 2 VB minus VC. So 2 VB equal to VC. Right? So you substitute VC inside the first equation. You get the third equation you see on the screen. Makes sense? Makes sense, right? So here you can able to find relationship between VA and VB. So at the end, you get 0 equal to VA plus 4 VB. Then you substitute the speed. Again, speed that you see in the question is positive. Look carefully on the datum given. VB in the question pointing up positive, 6 meter per second. However, the datum is positive going down. So when you substitute the velocity, be careful. In this case, move up, you get negative 6 meter per second. Substitute inside, VA will be positive 24. Where is the positive direction? Go down, referring to datum. Okay. So this kind of question will ask you to solve velocity at a certain time and then ask you what is the expected motion, whether go up, go down, move left or move right. Okay. Let's look at example 17. Example 17 is a construction example. So there's a man hoisting a safe S, this one, by walking to the right at a constant velocity. So this safe, this object S, pin to the pulley D, and then pull, and then move in VA. Again, you're dealing with vector. Vector have magnitude and direction. Vector, you can split into X and Y direction. Okay, so be careful on solving. The previous example is straightforward, but this is not straightforward. Right? Okay, then what information you have? Determine velocity acceleration of the safe. So you're focusing on the S object. When it reach the elevation of 10 meter, You want to look at what happened when you reach point E on the diagram. Rope is 30-meter long. The total length is given. Pass over a small pulley at D. Okay, so how to find the total length of the rope? How do we find? Nico, what is the total length of rope? Okay, what is the length C to D? Yeah, C to D. 15 minus Y. Okay, then how you find D to A?
X square and then
Okay, so there's a triangular here. Okay, so you square this one plus square X, then square root, you get. Okay, good. So basically, it's still the same, still the same. Okay, still the same, huh? But this one you break into X and Y. The rest notation on the screen you read, huh? So the total length actually was given. Rope is 30 meter, but the length changed with time. All right, but the calculation of the section is what we discussed just now. Okay, so total length is 30 meter. So you break into total length equal to LCD plus LDA, like what we discussed just now. So how to find CD and CA? Reduced by theorem, right? LDA equal to square root of 15 plus square root X. Then you, right? Then you get LCD equal to 15 minus Y. And you know that total length equal to LDA plus LCD. You combine this one and this one, you get one long equation. Then don't worry, you're still doing the same procedure. Once you get total length, you do time differentiation, you get velocity. You do time differentiation again, you get acceleration. Then you substitute all the known equation. Okay, so in this case, you're dealing with X direction and Y direction. So you rearrange, you get Y equal to something, right? So you time differentiate. You have two directions, right? One is in X direction, one is in Y direction. So you have vertical speed and horizontal speed. So if you differentiate vertical dy dt, right, of the speed, you differentiate this equation, and the velocity at A equal to time change of X direction. So you get VA equal to dx dt. So you have these two, right? So you need to do chain rules. So Vs dy dt, you break into chain rules. Dy dt equal to dx dy dx dot dx dt. You do chain rules. So again, go read appendix D, right? So I will not go deep into mathematics, huh? You go and study. So dy dx, you dy dx this one. The whole equation, you 1 over 2, 2x, and so on. Dot dx. Dx dt is your VA. So you summarize the equation. So you have one velocity there, and then you're given you need to find a scenario where y equal to 10. So at y equal to 10, your VA you know, right? So y equal to 10, y equal to 10, 15, and so on. Your x equal to 20 meter. Again, this is a square root answer. Square root have positive, negative. Be careful on the positive, negative side. Here, your x cannot go inside the wall. There's no negative value, right? And it's not possible to go inside. Then you get 20. Once you get 20, you substitute inside the second equation, Vs equal to something that we have x. Then VA you know, VA is 0.5. So basically, you can find your Vs. Vs equal to 0.4 meter per second. Where is the direction of your Vs? Go up or go down? Go up, huh? Why go up? How you know Vs positive value is go up? Where's the datum? Y go up, positive. Okay? Acceleration still the same. So you have two equations. One, y equal to something you derive from the earlier steps. Vs, you get one equation. So acceleration is a equal to dv dt or double differentiation here, position. So there are two equations that you can use. You can use this one or use this one. Differentiate this one 2 times or differentiate this one time. You get acceleration. I won't go into this one. Go home and do the time differentiation. Your A will get this one. Right? Go and do lah. But I will give you the steps in this one. Very lengthy steps. Go and look in this one. Okay. I'll show you the detailed step. Go home and do it. Okay. Again, this kind of question will be your final exam standard. Okay, so once you find the acceleration, you get one equation that you see on the screen. AS equal to 225 VA square divided by 225 bracket x square 3/2. At x equal to 20 meter, the okay, because the question give you the y, so at y at 10, you get x equal to 20. So boundary condition, you can find what happened at x is 20 meter. You can find what is the acceleration. So you just substitute the value. Then you get your acceleration at x equal to 20 meter, at y equal to 10 meter. The answer is 0.0036 meter per second square. And this one is moving up because positive value. Okay. Then the speed of acceleration of A will be 0 because it tells you it moves at the constant velocity. Right. The question tells you that the object moves at constant VA. Okay. Any question? No, you need break? Break, Okay. We have today we have 2 hours.